advocate for IPC, which is the Interplanetary Consensus. You might have heard about it yesterday. I've also been, so if you've been around the Filecoin ecosystem, I'm also the developer advocate for Filecoin Virtual Machine. And currently my team, you've seen Matt, you'll see Longfei, you'll see Robert. We all work around these two products at the moment, which is a very natural progression, right? Because if you've been using FVM, you know, it enables you to build on Filecoin. And I guess a big question that we've been having for a very long time is that when you build on Filecoin, the block time is about 30 seconds. So if you want to build an app, it could take a little bit longer for your transaction to run, which is not at parity as to what, you know, is needed in real world implementations. So really excited that we have IPC getting off the ground. It's still in development phase, but there are a lot of things that you can hack with already today. So I'll be covering some of that in this hackathon and answering some questions. With IPC, it allows you to spin up subnets, whether you want to spin them up and shut them down, or you want to spin them up and let them run for a longer period of time. It will allow your dApp to run much faster, which is really awesome to see. So we're hoping to see some use cases come out of that through your project submissions for this hackathon. So also, this is the first hackathon that we're doing with IPC. So the team is here to handhold you guys. If you have any questions, we know that a lot of these features are experimental. Beware of dragons, but we'll be there to help you along in the Telegram groups as well as the Discord groups. Yeah. So I'll get started today and kind of run through what we're going to cover through this talk. Just before I begin, I just thought that the IPC logo kind of looks like the Doctor Strange one, which is cool because it enables you to really unlock a lot of different use cases. So I just, yeah, am I the only one that sees it? Anyway, so I put that in. Cool. So goals for today, some questions we'll cover. I know there have been a lot of questions. We've been taking them in the Filecoin Slack as of now. IPC will have its own Slack and all in a few months to come, but right now we are all on the Filecoin Slack. So we've been having some questions come in, right, which is around like why use IPC for scalability. There are a lot of great innovation and progress in terms of the scalability market recently. So there are a lot of solutions out there, but I'll cover how IPC is unique to that and some of the developments that are coming in really soon. Another question is, what can I hack with today? So as is experimental, there are some features that are still in development. We'll be giving you the latest updates and dropping them into the Discord as well as on our Twitter and on the main Discord, so make sure to follow us there. So I'll run through some of the features that are available for you to use during this hackathon, as well as some upcoming pieces, because we know it's a month-long hackathon and we're working really quickly to give you more tools that you can use. But definitely some of the P0s are there that you can already use to hack with today. And then the last question will be around what you can build with IPC. So again, this is open-ended, really anything that you can think of, but we have some ideas that we've come up with as a team that we're really excited to see come from you hackers. So we'll cover some of those cool ideas as well. All right, so a quick recap. So if you missed the session yesterday by my teammate Matt, he ran through a really quick vision, a high-level vision of what IPC is meant to accomplish. If you missed the video, you can watch it over at this QR over here. Super useful. I will suggest that you tune into that if you haven't done so already. But a quick recap, just so that we can set some context for what I'm going to run through today. Here are some main points on what IPC is going to achieve. So one, it enables horizontal and vertical scaling through parent and child subnets. So hierarchical consensus is something new that we're bringing to the scalability space. Parent and child subnets is this really easy concept of like you can have a root net on an L1 and you can continuously spin up more and more subnets and go really deep scaling vertically. You can have L3 plus and so on. That is the vision for IPC, and so you will be able to shard your dApp accordingly as deep as you want, or you can spin it up and shut it down. Of course, there are security considerations as and I'll run through them later on, but as you spin up more and more subnets, your security layers get further away from the root net and so on. But this is based on whatever use case that you're trying to build for. Another big piece is around it being deeply customizable. I'm going to run through some core components to address. So I know Matt gave an overview of the architecture yesterday, but I'm going to run deep into some areas on how we actually achieve customization within IPC and how it is different to other solutions out there today. And then lastly, I think the main use case for IPC here is for sharding ecosystems, dApps. You can spin up app-specific networks and go deep vertically, but you can also run them multi-chain across different subnets routed to various different root nets, right? And then enabling cross-chain communication across those. So those are things that are enabled actually today already. So it would be yeah, we can dive a little bit more into that later on. It also, I think compute is a really big use case over here, and also it's a big, I know AI is a really big thing right now. We have some compute resources coming in really, really, really soon around ETH Denver. So I'm going to cover some of that, and you can look forward to them in the next week or so to come. But yeah, if you guys are in ETH Denver, we're going to be there too, and I'll share how you can keep in touch with us or meet us on site at ETH Denver. Great. So again, QR code if you haven't watched it already. Here's a quick recap visually on what IPC can accomplish. So you have, as I was talking about earlier on, you have a mainnet, which is your L1 rootnet, and then you can spin up various subnets, which, it can be a gaming subnet and a database subnet, and these two can relate with each other, running your entire dApp as a whole. Or you can provide them as services if you spin up different subnets, and you can continue to roll out more subnets on top of that for different purposes. So TLDR, that is the architecture for IPC. Cool. So I'm going to run through a little bit on how IPC compares. We get a lot of questions around how it's different in the scalability space. There are a few core pieces to take note of here. So one, it's a scalability framework. So it's not just a rollup or a sidechain, although you can customize your subnets to resemble or operate like a rollup or a sidechain. That's up to you. Consensus is fully customizable, as well as we have potential for multi-chain rootnet capabilities. So right now we are focused on deploying onto the Filecoin rootnet for now. We have some things like token bridging that enables you to bring tokens across from a different L1 into the subnets that are routed onto Filecoin at this point of time. So that's already available today. Again, all this is experimental, but we have resources for you to use. And then moving forward from that, from Filecoin, we're going to be working on Ethereum as well as Bitcoin and more chains to come. So we also invite a lot of developers or hackers to build with us. Coming out of this hackathon, based on your project submissions or your interests, we have an early builders program that I'm just going to call out a little bit here. Similar to what we did for FVM, as we continue building IPC ready for launch, we want to work with builders who are super keen to build out this scalability space, interested and enthusiastic about the vision for IPC and want to be part of the launch. So we'll be reaching out to hackers throughout this hackathon to see if any of you are interested to join our early builders program. Okay, so when it comes under the hood, right? So we have Tendermint, which is a version that we've built up, kind of like an adaptation of Tendermint Core. So we use Tendermint Core under the hood. We don't use it with the Cosmos SDK, which is written in Go. And the cool things about Tendermint Core, right? So it is a generic blockchain SMR system. It's generic in the sense that it allows us to plug into our own application logic, regardless of what language is written in. So this allows you to write really in any language that you want to. And not forgetting the fact that we also run FVM on our execution layer, which runs Wasm time under the hood. So again, another layer of customization to use frameworks that you are familiar and comfortable with to write your application logic. Tendermint blocks are also finalized before they are executed, which means that this allows you to not have to roll back the state, not have to have reorgs. The application itself is able to apply a block of transactions and commit it at the end when Tendermint says so. And also allows us to combine it with IPLD, because again, we don't use the Cosmos SDK, and this allows us a lot more configuration. So we have complemented it together with the IPLD store so that messages can be stored in a CID format. And I'll talk about why that's important in just a bit. We also use ABCI++, so that I'm sure all of you are familiar with. We've implemented the latest version of ABCI, which means allows you to take control of which blocks can become part of the chain when they are finalized. It allows you to reject blocks that propose bottom-up messages that you cannot resolve from the child subnet, and you can also reject blocks that propose top-down messages that aren't final in the parent subnet. So this allows you a lot of control over the kind of messages that you want to execute. It's based on voting, based on the messages that you put in before they are it allows you to vote on them before they are actually executed. So it allows you to reduce the amount of inefficiency within your subnet operations. And then we have IPLD. So this is specific to Filecoin, but it's a really cool piece of technology. If you're not familiar with it, IPLD is really good for storage efficiency. So one of the most prominent places it appears in IPC are the cross-chain messages. Checkpointing, I'm sure Matt has touched on this yesterday. So checkpointing allows you to checkpoint the state of a child subnet into your parent subnet so that it gets finalized. For checkpointing, it actually contains a list of CIDs of the checkpointed messages, or a CID of a data structure that contains a list of more CIDs, right? So these refer to your messages, and you can always easily, rather than porting over all the message informations, you could easily, we actually have a messaging enveloping feature, so that takes only the crucial metadata that you need for those messages and then checkpoints the entire state onto your parent subnet, which then makes it a lot more efficient for storage. It's also a graph, so that's easy to track. And there's also no need to necessarily duplicate the entire message for each level in the hierarchy. And so we should be able to reclaim some efficiency by reusing the CIDs within messages and only wrapping them with what you need, right? And then also for state persistence, IPLD is a really useful tool to have. So all in all, this allows you to have really good storage efficiency, allows you to be super customizable with what you're trying to do on-chain, on the subnet. A few things in the future that we are going to be developing really soon. So these are features that are still in development. Flexibility for IPC, I think, and if you look across the entire scalability space, these are features that I guess we all want to look out for, but in other solutions, they might be compromised or they might not have those certain configurations. But in IPC, our goal is really like hyper customizability. So for us, we have configurable interoperability. So there are no defined bridges that you have that we are fixed, that we fix for you to use. It's up to you really what you want to use and what you want to configure within your subnets. I would suggest you really play around with the syscalls and the built-in actors, and we have a workshop on that coming up as well. We also have configurable security. So as a default, your child subnets will always borrow security from your parent subnets. But it also allows you to configure them when you set up your child subnet and how you want security to be managed. It's truly permissionless. So in terms of like anyone can set up a subnet, anyone can shut down a subnet. Of course, as a subnet operator, you are also able to set the permissions on maybe some addresses that you want to allow to join as a validator or set up more subnets on top of your L2 subnets or L2++. It's up to you. That's configurable as well. And we also plan to be multi-chain, which I mentioned earlier. We also aim for efficiency. So we put a lot of features into this, right, for configuration, and we want to make sure that it's as efficient as possible. What this means is that, we have ephemeral subnets. You can set them up and shut them down for specific users, so that will save you on cost. It's a lot more cheap and efficient. We also have partition tolerance, which allows you to set up a subnet that can operate without having to be connected to the root net. So that allows you to, again, achieving the truly permissionless vision that we have. High upgradability, which doesn't affect your operations. So on the main IPC client, we have like contracts that are upgradable right now to make sure that there are no stale contracts, even as we upgrade them as the core engineering team upgrades them on the back end. Or even within the subnet, allows you to upgrade your contracts without affecting the other subnets that it's connected to, whether it's a child or like a parent to the child subnet that you are running. And then lastly, we have data availability within subnets, within individual subnets itself. So that should allow you to be much more efficient when using IPC. And all in all, I think these are the core features that we think makes IPC really unique as a combination of all these top features that a lot of people are looking for within the scalability space. So again, if you're interested to build this out with us, tune in to either our Twitter account or our Discord. We are looking out for early builders to build IPC together with us and implement them, try out new features. So for example, we have some teams that have already started implementing their own user-defined subnets with IPC to run as a whole product. So we'd be interested in teams that are interested in doing so. Yeah. Cool. So what you can use for IPC in this hack. So I know I ran through a few different features that we have. Right now, because IPC is experimental and in development, there are some features that are still progressing in development. So I'll run through what you can do today within IPC. So we have so for general message passing, right now, we recommend that you deploy a subnet up to L2. So on top of routed to the L1 Filecoin calibration net, the best recommendation is to build a subnet L2. I think for now, we are mostly focused on single hop GMP. So if you were to spin up an additional subnet, which is the L2++, it might be a little bit more difficult for you to do a multi-hop GMP across subnets. So right now, the easiest for you to keep to an L2 subnet. And we'll have a workshop coming up on how you can do those cross-net messaging, what you need to take note of when you set up contracts. You need to be IPC aware so that they can communicate with each other. So we'll run through that in the workshop in depth. Look out for the schedule and join that GMP workshop so then you can set up your dApps and allow for efficient cross-net communication. We also allow, right now we are able to bridge tokens. So this is really, really fresh. Because XLR is implemented on Filecoin today, you can actually use it with the FVM. This was enabled by the FVM. We've also implemented that within IPC. So within the subnet, you are able to deposit your native supply from a different L1, let's say on Ethereum, into your native subnet, as native supply within your subnet that is routed to the Filecoin calibration net. Of course, there are things to take note of, like finality, but we'll answer that within. We have an FAQ section if you want to take note of what finality looks like when you're using the Filecoin calibration net. So these are things to take note of, but these are some limitations that we have right now for features, but it allows you to build with them for the purpose of this hackathon. We also have federated validation. So earlier I talked about having a truly permissionless vision. Right now, for subnet operators, we do require you to define the addresses that would be allowed to join as a validator. We're still working on developing fully out the security features and aspects of the subnets. So for now, you would have to define the addresses that will be able to join as a validator. So do take note of that. I'll be running through that during the subnet quick start workshop tomorrow. You can answer any questions there, but I'll show you how to do it yourself. Subnet customization as well. So we have basic configuration. You can set the number of validators within your subnet. You can set the chain ID. So these are basic configurations that you can manage today. For advanced configuration, and this is more for, it gets deeper into pretty low level stuff. We have a workshop coming up on it, but you can customize the syscalls when you set up a subnet and the built-in actors that come together with it, which will enable you to pull different functionalities from the Filecoin network. So if you're looking for maybe storage components or you want to enable some GPUs or ML workloads, you would have to customize some syscalls, do some configurations there, implement your own built-in actors within your subnet, within your custom subnet, and then be able to run those different functions. So really cool stuff, and that really unlocks a whole set of new features. We have some use cases for you, and we'll give an example during the workshop, but look out for that and see how you can implement this. And we're really looking forward to seeing people hack with this. We want to see what you guys built. We also have compute network. So there are a few compute network tooling coming in. As I mentioned earlier on, we have some teams that have already worked with us for the past few months to deploy their own custom compute networks on IPC. So you have Fluence that is coming in that will be available once ETH comes around, which means next week. Look out for that announcement, and you should be able to use. So you could like read up more on docs this week, try out setting your own custom subnets, and then when next week comes, once the Fluence compute network is available for use, they will be launching at ETH Denver once again. You can easily use that compute network to run really ML, LLMs, and so on for your project submissions. We also have Co-op Hive, which is a compute network. So if you've been in the FVM space, you might have heard of Lilypad. This allows you to do decentralized compute via a smart contract. That should be available by end of this week, early next week, so that you can easily implement it from calibration net onto your IPC subnet. So using the single hop GMP, you could invoke those functions within your IPC child subnet and run a compute project. So these are some features that are coming in and what you can use today. We're really looking out for, I think these are the really exciting ones. Of course, if any other questions that you have, you can always ask them, but this should allow you to build a project and get started. Yeah. Okay, so we're gonna run through some hackathon project ideas. Okay, sorry, I'm not a Marvel nerd, but like again with the how IPC logo kind of looks like that. Anyway, so there are a lot of ideas that you can come up with that. I'm gonna run through some of them. So here are some cool ideas that we've thought of just to give you some inspiration. Again, this list is not exhaustive, right? So if you have new ideas, anything, you can definitely bring them up. So some cool ideas that we thought about, and these are all capabilities that are available on the Filecoin calibration testnet today. So deploying your custom child subnet on top of Filecoin's calibration net will allow you to use these functionalities. So we want to see how you guys are able to implement that. Some interesting things, you could implement a subnet with DRM time lock to prevent MEV front running. So it will allow you to inspect, or no, not inspect, actually allow you to not inspect those transactions before they get executed. So how can you implement the DRM time lock contract onto your IPC subnet? We'll be interested to see how that runs. You could utilize deployed compute networks like I talked about earlier on to run LLMs or AI and so on. So definitely in the compute space, I know we have a challenge statement for that. We want to see how you guys are able to utilize that as well. You can run a turn-based game on the IPC subnet. We want to see how fast you can actually get this game to run. So do consider, and I think you have to configure some custom syscalls, but we want to see how you guys are able to build a project around, turn-based games or games in general, right? I think the gaming space is a really big opportunity for the IPC network. implement cross-chain messaging with bridge tokens using Exceler. So this is, again, something really new that we've enabled, but we see it being super impactful. So how can you use enable cross-chain communication and cross-chain functions, being able to bridge these tokens across? UI tooling. So some of the tooling ideas that we have, again, IPC is something that's really new. We want to build out the ecosystem more. We would be super interested in working further with teams that build out tooling for IPC. So for example, UI tooling, something really easy to use, like maybe a GUI or UI that allows, or on a website that allows you to do automated subnet deployment rather than running the entire Docker image yourself. These are more for literally, so more people can spin up IPC subnets as they go along. So that's one really good idea. The other one would be around a subnet explorer. So as we enable L2++ and more subnets to come, how can we build an IPC subnet explorer that is specifically catered to IPC and all the different features that it has? Right now, you would be able, we did spin up a testnet, and we were able to use Block Scout to build a really simple explorer, but we want to see how a subnet explorer will allow you to, view subnets within a single tree, view subnets across, and so on. So interested to see how you guys design that and maybe build that up. But yeah, super interested. Regional subnets is something else that you can look at. So with IPC, one of the big use cases for it is to use regional subnets defined to a specific region. This is important in terms of GDPR, privacy, and so on. And also for cheaper cost of computation when it's based within a certain region, bringing that model to the data rather than the database in that region, rather than pulling it across from different data centers all around the world. So for regional subnets, there are things that you can do, such as sharding a compute network with subregions and sub-second block times for data privacy. We have seen that implemented, I think, in Istanbul last year, but it was super early stage. But I think the team did a fantastic job of kind of showing a POC. So we want to see how you guys build it out further. You can also shard a transaction network to run much more efficient transactions across various networks for, let's say, a single application. So how can you best utilize that to show the efficiency of IPC? And then lastly, advanced configuration. So this gets more into the super advanced space. If you are a super great developer or really technically experienced, we want to see how you guys are able to crack this. Some ideas that we have are to deploy tiny ML workloads on IPC subnets and implement GPU syscalls via the customizable syscalls that you can join the workshop later in this week to make them run efficiently. Or you can implement an IPC subnet that runs homomorphic encryption programs. We have the Zama SDK, which was built on Filecoin, and you can use it to run these programs within an IPC subnet. So this gets into more of I'm not a compute pro, but if you are and you want to try to hack these, we would love to see some people trying to build this out. We give you definitely points for effort, for sure. And we want to see how we can take it further with the early builders program as well. So yes, these are some hackathon project ideas for you. And then I hope this answers some questions. Again, this list is not exhaustive. It's really up to you on how you want to ideate and build really cool things. So I don't have all the answers, but we are here to work with you. If you have any questions that come up, we'll be around in Telegrams and Discord to answer them. Yeah, and so to get started, really, I hope this answers some key questions for you to get started with IPC. We have a subnet quick start tutorial over here. This was really recently updated in the past day. So we have automated scripts that you can use. If you haven't checked that out, do check it out. We'll be running through that tomorrow and taking your questions. Also check out our doc site. Those will have a lot more resources coming in the coming days. And we're available on Twitter and Discord, as I mentioned. So yeah, pretty much that's it. And if you want to see where you can catch us at ETH Denver, we will have our engineering lead, our research lead, the full DX team from my team there in Denver in person. We are giving some talks and workshops, so you can catch us. We'll be putting up the calendar this week on the IPC website, so do follow that if you want to see where you can find us in person. Cool. Thank you.
Amazing. Yeah, thank you. Thank you very much, Sarah, for this very exciting technology revealed. Definitely looking forward to see more development of the IPC and see some of the exciting submissions during the hackathon for the IPC tracks. Yeah, I think we can wrap up here. It's been a long time workshop sessions, but all three sessions are great. I definitely do believe that all three workshop sessions will be like super useful and helpful for the devs who want to join a hackathon. So definitely check all of the recording of the workshop sessions later on the link that we will post it later. Yeah, looking forward to see all of the developers that submitting to the hackathons. And feel free to reach out if you have any questions. If you haven't joined the Telegram channels, feel free to do that. There will be teammates from both Filecoins, from sponsors, and from DoraHacks to be there to answer any of the potential questions that you guys might have. Yeah,
Thank you.
that'll be all for today. Thank you very much, Sarah. Thank you for all of the audience for joining us today. And see you guys soon. Bye.